Hello. In this video I'll be talking about Morganucodon, a small shrew-like creature which was supposed to have lived 200 million years ago. Morganucodon is claimed to have been a mammal-like creature, and here is a picture of what it might have looked like. But notice that the body was reconstructed from fragmentary fossils. Nevertheless, the important thing about Morganucodon is the fact that it is claimed to have had a double jaw joint, and this is a key step in the supposed evolution of mammals, and in particular the evolution of the jaw and middle ear bones. Why is this important? This is important because evolutionists need to explain how the mammal jaw joint evolved from a reptile-like jaw joint. Here's a diagram showing mammal and reptile skull, and the top diagram is a mammal, and you'll see that the jawbone or mandible is a single bone called the dentary, and the jaw joint is formed between the dentary and the squamosal. Reptiles, however, have several bones in the mandible, and the jaw joint is formed between the articular and the quadrate bone. Morganucodon, which is claimed to be a mammal-like creature, is believed to be evidence of the transition from creatures with a quadrate articular jaw joint to mammals with a dentary squamosal jaw joint. This transition is said to be well documented and an important demonstration of a transitional form. But just how good is the evidence? One key fossil of Morganucodon was found in Wales, and a detailed description of the skull was published in 1981 by Kermack and his colleagues. This is a key publication which is widely quoted, and diagrams from this paper are repeatedly redrawn as evidence of a transitional stage in the evolution of the mammal jaw and ear bones. But what I want you to notice, as highlighted here in red, is that the jaw joint and the middle ear bones are actually missing from this skull. Nevertheless, Kermack and his colleagues recovered other small fossil bones, and from these bones and the skull they were able to reconstruct what they thought was the jaw joint as shown in this diagram here. And this is a view from the underneath, but I want you to be aware that the complete lower jaw dentary was actually missing from this specimen. Furthermore, the squamosal was incomplete and was not attached, and the glenoid fossa, you will notice as shown here near the red arrow, was quite large, and this was the depression into which the dentary bone fitted, giving a rather large dentary squamosal jaw joint. The quadrate itself was not attached, and the quadratojugal was actually missing, but its position is shown here with the green arrow, and this was supposed to have been important in forming the reptilian jaw joint between the articular bone and the quadratojugal and the quadrate. Also notice that the stapes was incomplete. So there are various bones in this reconstruction which are shown in dashed lines which show that they were incomplete. Here is another diagram from Kermack et al. Showing a view from the front, and I want you to notice that the location of the squamosal, the quadrate and the quadratojugal were all actually inferred because the stapes was incomplete as shown by the red arrow here, and the quadratojugal, as I've already mentioned, was never found, so the position of the quadrate itself is also inferred. In fact, the whole reptilian jaw joint here cannot be reliably reconstructed because of these bones not being attached and having to be reconstructed later. So in conclusion, the jaw joint was actually guesswork. Quadratojugal never actually existed, and in fact in later publications which redraw these diagrams, the quadratojugal is just missed out. Nevertheless, it is still claimed to be an example of a double jaw joint. But I would like to suggest to you that the evidence for the mammalian jaw joint is actually much better than for the double jaw joint. And if this is true, then Morganucodon was not just mammal-like, it was actually a mammal and not a transitional fossil at all.